Hello, my name is Melissa Runfelt. I'm a founding data scientist at QN. So QN is a platform for customer experience observability. We replace the need to manually mine support issues and analyze conversations by leveraging automated machine learning and generative AI to summarize agent actions and guide chatbot design. We can reveal and fix chatbot failures. We can alert on changing trends. And all of the things that we do are usually with the goal of increasing customer satisfaction and NPS while dramatically reducing cost and operational inefficiency. So today I'm going to talk to you about our most popular use case, which is chatbot optimization. To answer the question, are you flying blind with your chatbots? The answer is if you don't have observability into your bots and actionable insights into how they interact with your customers, you are absolutely flying blind. So I'm going to use Chappie today to guide our story. He's from a 2015 film set in a dystopian future where a defective law enforcement robot is stolen by criminals, and the robot battles to decide between right and wrong. And this internal battle of the robot centers on this idea of integrating new information into his original programming and dealing with the conflict of having multiple contradictory sources. So I want to start with a simple canonical example of how a chatbot is designed and how it can fail. So this example is for the banking domain. This is the customer, and they ask a question, what is my routing number? And the bot responds with the correct routing number. So in order for the bot to do this, it has to recognize both the intent of the question and then have an appropriate response configured to that intent. So in this example, the customer asks a follow-up question about a Swift code, and the bot is confused, which usually results in an escalation to a human agent. So in order for the bot to answer the Swift code question, it also needs to recognize the intent and have a response ready. So I want to note that this is a simplification. These responses, they can be static or generic FAQs, or there can be metadata associated with this user that's used to filter and identify the correct response. If there's not metadata available for the customer, the bot will ask questions to collect the appropriate data. And this response can also come from a query or an API endpoint. Like, for example, the customer was asking, what's my account balance? She probably will need to be logged into her account, and the response will be made by making the appropriate API call to a secure endpoint. I also want to point out one more nuance is that not all chatbots use this idea of intents. You can definitely have bots that go directly from Q to A. But either way, even though this is simplification, the basic paradigm is the same. The bot has to recognize the question, has to map it to the appropriate response. So imagine you're a company designing a brand new customer support bot from scratch. So anyone starting fresh has to face the cold start problem of not having real data. So you string together what you can. You might generate synthetic data or modify an open source data set. If you have historical customer interaction data like emails and cases, you can mine through that and utilize it. Either way, you have to make a lot of guesses or and assumptions about how your bot is going to interact with real customers. So once your data set is ready, there are a lot of great bot vendors available that will train a chatbot on your data and produce an F1 score from the train test split. But that F1 score is only going to be as good as the data that you feed it. It's only going to capture that data. So here's an example, a scene from the movie Chappie, and this is the scientist who created Chappie. He's assessing his recognition capability. So he's testing his bot on the questions that he's thought of asking it, like, can you classify this watch? But what the scientist isn't thinking about is all of those unknowns and known unknowns, like what happens if Chappie is stolen and forced into a life of crime? So if you're proactive, like most companies are, you're recording metrics for your stakeholders. Stakeholders are the people who are held accountable, your product team and your executives. And common metrics that they use to monitor bots are deflection rate and survey CSAT, and then also, of course, custom business metrics that are bespoke to your use case. And so now that your bot is ready, you release this black box into the wild, and like, what could possibly go wrong, right? we all know some stuff goes wrong. If you've ever used a chatbot, a consumer chatbot, you're familiar with a lot of the frustrations that can happen. So in this example, this is from consumer banking. Here's the customer question asking about a charge on their statement. There's a typo. The bot didn't understand it, and the customer has to reword or rephrase their question. And we all know this is very frustrating. Nobody wants to rephrase their questions for a bot. Here's another example where we have a question that's around pricing. This question is unhandled, so it's escalated to a human agent, but that agent isn't immediately available, so the customer gets frustrated, abandons the conversation, and this is a sale, so the sale is lost. And here in this final example, this is an example of misclassification or incorrect bot response. So here the person wants to know their seat number. The response of the bot is to show seat fees and seat maps, which are not what the customer asked for. And so we know this is really incredibly frustrating as a user. It makes you lose confidence in the service and really just not want to use it. So how do we even begin to fix these problems? Well, observability, end-to-end observability, of course. So you need to connect all of the information sources across your vendors. Many companies have voice, chat, agent, SMS. All of this needs to be processed and collated into a single location. You need an automated ML pipeline if you're going to be able to serve insights and solutions in real time. And it's 2013, people want it in real time. So to do this, especially for multiple customers, you have to tackle scalability. And that's what we do at QN. For each customers, we pull data from multiple sources. We extract hundreds of signals from millions of conversations and surface the insights in our UI and through APIs. We use a combination of supervised and unsupervised machine learning approaches. For supervised learning, like we're seeing here, this is a cartoon example of a conversation progressing through time. So if you're doing supervised learning, then you have to provide the labels for these conversations. So you have to tackle this need for scalable, high quality, consistent labeling. Our platform is also multi-tenant, meaning that each model is trained on an individual customer's data independently. And as you scale up a multi-tenant ML pipeline, you need to be using some sort of auto ML solution for hyperparameter selection and sanity checks. So you're not bottlenecked by needing data scientists to tune parameters and review outputs. So after applying structure to this conversation, identifying categories, we will group, filter, and rank. And then we'll also surface these insights in both our UI and as well as the APIs. We use APIs as well so that customers can integrate them into their existing solutions. For the unsupervised learning that we use for grouping or clustering the data, we use labeled pairs to seed and evaluate our clusters and to build in checkpoints for sanity checks. And I kind of like a tip of the trade, you really want to be looking at not just like the output of one single model in your pipeline, but what those final results are going to be at the customer's end. So it's really helpful to have a great UI and dev environment so that you could rapidly iterate when you're evaluating new models. So most of our models are in-house, but we're always comparing and adapting open source and paper prediction, API-based models, because everything is getting better really fast these days. I would say this is a tip of the trade, though I'm pretty sure everyone here is very familiar with it. You have to keep up with the newest models, especially in the NLP space and the deep learning space. They're getting better fast, and people have expectations set that your models are going to be performing as well as what they're saying in the media. So this is a really large undertaking. It involves engineers and data scientists working closely together with each other and with their customers to surface the information that provides the most value and actionability. It's definitely a hard problem, but I can tell you as a data scientist, it's really rewarding to see your customers' excitement and delight when their data is displayed in front of them in an accessible and actionable way. They're like, my data. Sometimes it's like they're really seeing their data and their customers for the first time. So what all of this work and process provides for you is transparency into bot health. So in this scene from Chappie, one of his new parents is painting with him, and it's allowing her to observe and influence how he sees the world. For customer support bots, the features that you want to observe and influence are user frustration, conversation abandonment, and incorrect bot responses like we had seen before. We also identify bot confusion and loops. Loops are when they ask a series of questions over and over again. So we look at bot health, but of course, bot health on its own provides a pretty flat view if you can't also ascertain what your customers want and how they feel. You want to know what your customer's intent was. You want to know what their emotions are throughout the conversation. You want inferred CSAT. And you want to know what the final outcome is. And I want to emphasize using inferred CSAT here because you don't want to rely only on survey CSAT because most customers don't fill out surveys. And it ends up the customers who are usually filling out the surveys are either very happy or very unhappy. You really want to capture that full range of customer satisfaction for every user based on what the content of the conversation is. So in this scene, Chappie is learning to fist bump with his new friend, which requires not only knowing the correct action of the fist bump, but also being tentative to the movements and feelings of his human ally. Finally, you want to be in control of what your bot learns. This is becoming increasingly important as we move more towards automation and active learning, and especially as we start to really implement generative models and move away from intent sets. Whatever your learning paradigm is, you always want to be the human in the loop telling your bot, okay, listen to this data source, train on this data, and don't train on this other data set. And that's what's happening in this scene. Chappie's creator, Dion, is telling him, I'm your creator. I care about you. Please listen to me. So on the subject of learning from humans, one of the biggest advantages that companies can take in training their bots is to utilize the successful solutions that their customer service agents are offering. So here's a common scenario where the customer asks a question and the bot is confused. So then it escalates to an agent. A lot of times the customer will have to re-ask the question and then the agent will offer a solution. So what you want to do is you want to train your bot on these solutions, but not any solution. You want the best solutions. You want the ones that make your customers happy. You want the solutions that don't violate your policies or leak profit. You want to decide who your bot learns from. You want them to learn from your good agents, not from other people. These could be bad actors. They could be bot abusers. They could be agents who aren't following policy. So once you've filtered and collected and processed this data from thousands of conversations, what you can do is group together questions that have the same intent, and then group and summarize the solutions from the agents provided for each intent. And that'll provide you with a list of intents and their corresponding responses, as well as real-world examples of how customers are expressing those intents. I would say, of course, you probably want to have someone from your company review this data before configuring it into your bot. I personally think it's a wise and ethical decision to have an informed decision maker evaluate what's being fed into your bot before surfacing it to your customers. But once you make that very complicated ethical decision, then you just have to update your bot and you equip him with the ability to comprehend and correctly answer new questions. And what this entire automated process allows us to do is it gives us the ability to iterate on, gives you the ability to iterate on your customer experience workflow at least 100 times faster than if you have an in-house team doing it manually. Observability gives you speed, it gives you agility, it gives you insight into new trends, and it gives you confidence that you're earning your customers' trust. so that the next time the customer is channeled to your chatbot, their first utterance isn't agent please. And we do see a lot of that, agent please. Okay, so here is a demo that I'm going to share with you. I'm going to show you how we use QN to improve chatbot comprehension of customer intent and generate knowledge bases directly from the solutions that customer support agents are providing. I'm going to So this is our connector page. This is where you select your data sources, wherever you interact with your customers. We have connectors for multiple voice and chat vendors. We're always adding more. Today I'm going to walk through a demo data set with a bot that's configured in Salesforce. Let's go to our trends page, and we can see some of the top KPIs like deflection rate and inferred CSAT. You can see the trending patterns underneath, which are grouped and ranked by customer intent here. So this is sorted by the most common intent by volume, and the top one is needing a boarding pass sent or emailed. You can see the KPIs for that pattern, as well as example utterances. You can click on this example and see the full conversation, which I always think is lovely. I like to see the raw data. You can scroll down and see other common patterns, wanting to know your seat, change the seat, book a flight. We also have a semantic search. So you can type in a question here and see the pattern that matches the search criteria. And these patterns are ranked by proximity to that search criteria and volume. So here the question is wanting to know your seat number, and the top one is corresponding to that question. We have our examples here, as well as more statistics. We have several statistics that we surface. My favorite is the multi-intent flow. This lets you see beyond the initial intent that the customer expressed and view their follow-up question. So you can use this to design your chatbot flow and have your bot preemptively offer the next step. So for this initial intent, the most common follow-up is needing a boarding pass, wanting to change your seat assignment. So you could update this flow to have the bot offer these actions before the customer even asks. We have emotion, location, and inferred CSAT, a number of other statistics that our customers have found useful. We also have here, we can access our full conversation view. So this is just the intent view, but here we go, and you can see the full conversation flow. So the user starts with their intent of wanting to know their seat number. The agent collects information. Sometimes there's a second intent and a response by the agent. So you can actually view in this conversation at a higher resolution, which is going to show you more variations. And again, you can see that there are multiple intents through the conversation. So these percentages are based on total conversation volume. And it's 3% of the time that we see these users expressing all three intents. What's my seat? Change it. Send me a boarding pass. So now I'm going to go to another domain or data set. This is a consumer banking data set. And you can see we have a similar format with KPIs and patterns beneath, but these are specific to this banking data set. Here's the top pattern of wanting to know about a fee. We have new card, expires. And then we can go to our conversation flow directly from here. And I need to change the date range for this data set. And then we can see this flow for the intent that we selected around credit card charges and fees. And this is showing us that 89% of the time, customer starts with the intent and then the bot gets confused. And there are two different paths. There's one path where the customers get escalated to an agent responds, collects some data, and conversation ends. For the customers that didn't go to an agent, the conversation we can see that we surfaced here, there are multiple unhandled utterances. So these were cases where the bot got confused, and we can export those directly into Salesforce. And that creates a mapping between those questions and the actual intent. So we're logged into Salesforce here as an admin, looking at Einstein Bot's intent sets, and we can see the intent that we just exported around credit card charges and fees, and all of the utterances from customers that were previously unhandled. So next time this bot is trained, it should understand this question and have a concept of the intent. So understanding the question is only half the battle. Your bot also needs the correct response. I'm going to use this routing number as an example to show you how we do that. So here the customers are asking about routing number. We have a happy path where the bot understands all of those utterances, and the unhappy path where the customers are all asking about a Swift code, and the bot's getting confused and transferred to an agent. So we can see all those unhandled utterances here, as well as the successful ones below. And we can see all of the agent actions for this flow, and 100% of the time, the agent is simply providing the Swift code, which is specific to the bank. We have an option here to export this agent action as a knowledge article directly into Salesforce. So we export. And once you do that, we can see in the Einstein Bot's knowledge articles, the Swift code. And here we have the question and the answer. We use generative AI to create this canonical question and define what the answer should be, though customers are welcome to tweak it. And so voila, here we go, end to end. Did you think that was cool? I think it's cool, but I might be a bit biased. So in that demo, I showed you how you can update a bot. No, don't repeat. You can update a bot to answer new questions. Before I let you guys go, I want to touch on some of our other fun use cases. So what I just showed you was how you can update an intent set and knowledge base. And this is just one aspect of continuous optimization for your chatbots. The other aspect of continuous optimization is identifying and acting on new trends. So you can imagine if you're any company that is in retail and sells stuff, you can imagine that if all of a sudden customers are asking about some new payment processor and the bot is misclassifying their intent, you need to be able to catch that. You need to be able to generate an appropriate bot response right away so your customers aren't frustrated. But you also probably want to support that payment processor so you're not losing out on sales if you're not already supporting that. So the second part of that is also an aspect of product feedback. The idea behind product feedback is that you're using aggregated data that's coming in real time to directly from your customers that can help you inform your product decisions. So another example of product feedback, imagine like your clothing retail brand, you might want to know why people are returning their items or why they're canceling their orders. That information is being provided by customers in these conversations. Like when we surface these root causes that will help identify those reasons why they're doing the thing, because there's a lot of value that you can find in the why. We also do live agent performance. This includes coaching and monitoring. So for coaching, we can generate concise FAQs from internal docs, and monitoring, examples of monitoring are assessing whether your agents are adhering to your policies and what their customer satisfaction levels are. And finally, one more use case that we've experienced is contact reason taxonomy. So some companies have this, their own concept of what a contact reason is. And so they label each conversation by that contact reason, and they use those labels for routing and monitoring. So what we're helping them do is identify and define new contact reasons, because real world data is always changing. And with that, I'd like to thank you for your time and your attention, and for Rise for having me. You can contact me, Melissa at qn.ai. We're on LinkedIn and Twitter, and we are also hiring. So if you go to qn.ai careers, you can see some positions we're hiring for. Thanks again. Take care.